Okay. So to summarize, all the triangle congruences for which we are responsible, right? We've talked about angle, side angle. We've talked about side angle, side. We've talked about side, side, side. And now we have angle, angle, side. Okay. And this is kind of the full summary of triangle congruences for which you guys are going to be responsible. There's one other one called hypotenuse leg. Okay, for right triangles too. But I don't think we're going to get to that, okay? So we're not going to worry about that right now. But hypotenuse leg too. If you have the hypotenuse of of a right triangle is congruent to the other hypotenuse, and one of the legs is congruent to one of the other legs, then you're guaranteed that those two triangles are congruent. But we're going to focus on these four right here, okay? So again, I won't bore you with any. We'll kind of fly through this as much as we can here. But these are our four main congruences, okay? So other, iterations, right? Side, side, angle, or angle, side, side. I won't write it the other way, of course. Not a congruence, right? Angle, 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 not a congruence, okay? But everything else, every other combination there works, okay? You'll notice here that for this scenario, angle, angle, side, are we going to expect the side to be between the two angles here? Is this side included between the two angles? No, right? Look at the positioning of the letters, right? Side is not between them, but one of the adjacent sides to the angles there. So here, for angle, side, angle, right, the side is between the two angles, right? It's included. Here it's not. Okay, here it's not. All right, so let's jump a little bit around here and see what we can do. So I think some of these proofs are already done for us, so we'll do something else here. Like maybe we'll look at page 285 here. Well, let's look at, on page 285 there, we'll do one of those. Okay. I'll talk through the first one, and then we'll do like letter B. Okay. They have it organized in a flow chart. I'm not a huge fan of these. I mean, they work all right. It's okay, but we'll talk about things here. So we've got that AC is congruent to EC. So AC, I'll go ahead and mark that. Remember, mark your diagrams, congruent to EC. And M is parallel to N. Okay, so I'll go ahead and mark that too. Parallel, right? So put little arrows there. And we want to show that triangle ABC is congruent to triangle EDC. Okay? So kind of follow the proof here, right? They start with given. They state their given right there, okay? And I don't know if you guys, if you want to, I'll write it right here. If you just want to follow along, that's okay too. So, whoops, what am I saying? Given. Statements, reasons. So again, if you just want to follow along with this one, I get it. Don't worry about trying to fill in the proof here. I'll just do it. So AC is congruent to EC, and M is parallel to N. And again, the reason for that is given. Okay. So we've already got one congruence right there. Okay. How can we use these parallel lines? Well, if you look here, right, we have parallel lines, and we have a couple of transversals. We have a transversal here. AE is a transversal, and so is DB. Okay, so we know that transversals with parallel lines create those angle relationships where we have congruent angles, right? Like alternate interior, corresponding, alternate exterior. They're all congruent, right? Which is helpful because we want to, use those here. So, for example, we can say that angle DEC, so this angle right here, I don't know why I put 2 marks there when I haven't done 1 mark yet. Oh well, we'll do it that way. So angle DEC, what would we say that's congruent to? CAB, alternate interior angles, right? So we can say angle DEC is congruent to angle CAB because alternate interior angles are congruent. And we got those parallel lines there. Okay, or alternate interior angles theorem, if you want to say that. They use alternate interior angles theorem. Okay. What other 2 angles can we name as being congruent here? EDC, very good, Madison. Yep, and CBA or ABC, however you want to say it there. So, yep. Angle EDC is congruent to angle CBA. And again, same thing. Alternate interior angles theorem. And if you look at it, we have two angles and the non-included side, right? Two angles and a non-included side. So we're done. The two triangles are congruent. Triangle ABC is congruent to triangle EDC by angle, angle, side. Okay. You can see it right there. Angle, angle, side, congruent to angle, angle, side. Okay. Does anyone see a different way to prove these triangles congruent? So, Avery, what do you say?
Well, it wouldn't be using angles or
The angle, angle, side.
Mm-hmm. But you could mark the vertical angles congruent.
Right. So, like Emmanuel pointed out earlier, we kind of have a bow tie situation going on here, right? We have the triangle and the triangle. We have vertical angles right here. And so, in addition to using angle, angle, side, we could also say angle, side, angle, right? You see, we have an angle, side, angle congruent to an angle, side, angle. So you also could have done it that way too. Okay, so you had a couple options there. Do I care which one that you use? No. Okay, so sometimes you'll have more than one way to do this. Okay, and in fact, truth be told, every angle, angle, side proof could be redone as an angle, side, angle. You know, and I can discuss that more if you're curious about why that is. But that's the idea. That's something we can say. Okay, so let's look at this one. Okay, letter B. I think this. Let me make sure this is one. I want to do this one. Okay. Let's actually go to letter number 5 because that way we have some space. We'll have some space. So number 5 is on the next page, page 286. This will be better, I think, because we've got more space there. Okay. It says to write a paragraph proof. We're not going to do that. We'll just do our 2-column, our good old friend 2-column proof. Okay. So why don't you guys go ahead, mark up the diagram there with the given information. So go ahead, take some time, mark up the diagram there with some given information. And if you're feeling confident or you think you've got an idea, go ahead and get started on the proof too, right? So take like a minute, at least mark the information on your diagram, and then maybe get started on the proof if you think you've got it, okay? Or you want to at least give it a try, right? And really, everyone can at least do the first step of our proof, right? Everyone should be able to. See, everyone should at least be able to get started on that very first step of the proof, right? You should at least be able to get started on that very first step of the proof. All right, so hopefully you have something that looks like this. Yes, I either recommend labeling parallel pieces. right? It's just helpful. I went ahead and stated the given information here. Okay, I went ahead and stated that given information. Okay. So, let's see here. Aubrey, do you have any idea about what our next step should be after we state the given information? What's another congruence that we can maybe come up with here? Or were you able to come up with another congruence?
I just got the
Okay, that's fine. As long as you got the given, that's good. Let's go to Emma. Do you have another congruence we could state here?
I said angle BAC is congruent to angle CPCTC.
Okay, how'd you get that? What was your reasoning, I guess?
Oh, no, sorry, can I finish that? Instead I could say like angle BCA is congruent to angle EF.
Very good. Yes, that's a good catch there. So, and then what would your reasoning be for that?
I don't really know.
You forget what the name of those angles are?
The corresponding.
Yeah, corresponding. Exactly right. Corresponding angles. You're right there. Okay. So you can say like corresponding angles theorem. Bless you. Okay, corresponding. I just use the angle symbol. The corresponding angles theorem. Okay, so that's these two angles right here. Okay. And Emma was wise. She caught herself. Okay, that angle right here and here, right? BACEDF, right? They look like they're going to be congruent, but we don't have that same relationship there because we don't know that BA and ED are parallel to each other, right? So in this case, BC and EF, those are our parallel lines, and this is our transversal right here. Parallel lines crossed by a transversal, so we have corresponding angles there and there. But here at A and D, we don't necessarily have those. Okay, we know that they're going to be congruent now because they're corresponding parts of congruent triangles, right? So we'll go ahead and then state it. We have our congruence, right? That's it. So step 3, triangle ABC is congruent to. So if I named it ABC, how do I have to name the other triangle? Anybody? DEF. You got it, Frank. Very good. Okay. Match up. A to B to C, D to E to F. And what would our reason be here? Angle, angle, side. Okay. And again, if the proof was asking us not just to show the two triangles are congruent, but if it was asking something like, prove that, if it said instead, so like instead, like prove, I don't know, that segment AB is congruent to segment ED. Okay, let's just say that was what we really wanted to prove there. You'd follow these same exact steps, bless you. You follow the same exact steps, proving that the two triangles are congruent. And then for the very final step here, we would just put, since the two triangles are congruent, we can now say, well then therefore AB must be congruent to ED because they're matching parts. They are corresponding parts of congruent triangles, so they must be congruent. Corresponding parts of congruent triangles are congruent, CPCTC. Okay? So that would be like the additional step that we'd add in there just to make that so. Okay, that's all CPCTC is. Okay? All right, moving on. I want to talk real briefly about this one, and then we can move into just looking at some CPCTC stuff real quick. But on page 288, okay, and we won't actually do this, but I just want to ask you. We're given here that angle A is congruent to angle D, so I'll go ahead and mark it. And that angle B is congruent to angle E. And we're asked to determine how we can show these two triangles are congruent. So what's an additional piece of information here that we could use to show that these two triangles are congruent? What could we use here? So, Madison, what do you want to say?
The slope.
The slope. Okay, so what do you mean by the slope?
Rise over run.
Okay, so the slope of what?
The two line segments, BC and EF.
Okay, so, excuse me, that could potentially work. But does slope show distance, I guess?
No.
No, and I guess no, but it could kind of maybe. You could kind of use that argument, but I think we could run into some trouble
Use the distance.
if it was, yes, I think we would use the distance formula there. Yes, exactly right. So if we use the distance formula to go from BC and EF, that would be what congruence? So if we show that BC and EF were also congruent, what congruence would that be?
Like the angle.
Angle, side. Angle, side, right? And of course, there's other options too. So Avery, did you have another idea about what we could do besides doing those two sides?
Well, I was just going to say that it was angle side, but I guess you could also find the slope of like AB and find the slope of DE or
Yeah.
the distance.
And again, I would say distance formula. Yeah, distance formula. It would be more ideal there. Yes, distance formula between A and B, between E and D. That would then be angle side angle there. But yes, that's the idea. So again, in the coordinate plane, we have the additional assistance of like the distance formula. And I know some of you are thinking, distance formula, what is that? It's got a square root and some squares in it, but that's all I remember. So yeah, we still don't want to forget that distance formula. Okay? All right. So, well, actually, let me just ask you guys. So I've been talking about CPCTC. Would anyone like to see another CPCTC proof just to make sure they've got it down, or do you feel like you're okay with CPCTC? Does anyone need to see another CPCTC proof? We all are feeling okay with it? You're not feeling okay, Jake? You want to see another one?
Yes, please.
Okay. Sorry, guys. It's all Jake's fault. Just kidding. I'm sure everyone else has got questions, Jake. I'm not trying to. Yeah. Yeah, go ahead. Yeah. No, we'll look at one more here. I'll do one proof as CPCTC. Okay. I'll just do it right here on a piece of paper, okay? Because there is a section in the book, but they don't really have a whole lot of proofs in it and stuff, so I'll just do one, okay? So bear with us here. And it's good practice, too, because it's also going to give you guys practice for, the kinds of questions that you should expect for, your test and stuff like that. Okay. Let's do, and you don't have to write this down if you don't want to. Again, if you really feel like you got it down, don't write it down. This will be recorded in the video too, so if you want to come back to it later and write it down, that's fine too. So again, I'm going to write down what CPCTC means, corresponding parts of congruent triangles are congruent. CPCTC. Okay. And so I'll just jump into a proof. And I guess, I'll just write this note. Used to show parts of triangles are congruent. Okay? So, example. Given. And we'll just do a proof. YW, segment YW bisects segment XZ. And also given that XY is congruent to segment YZ, we are going to prove that triangle XYW is congruent to triangle ZYW. Okay. Typical proof, I'll draw a picture here too. I'll draw a picture right here actually. Okay. Notice I am not saying, how we're supposed to do this proof, right? We're just kind of given power to do whatever we want here. Okay. So let's first mark our triangles. Okay. So for example, Jake, if we know that segment YW here bisect segment XZ, what can I mark to be congruent? What's being bisected here? a segment is being bisected. So that means what's going to be congruent here?
That means that XW is going to be congruent to Z.
Exactly. There's our there's congruence there. Okay. We also have this congruence right here. XY is congruent to YZ. So XY is congruent to YZ. Just like that. Oops, I'll use 2 tick marks there because we're talking about different sides. So we've got 2 congruences. Can we come up with anything else? What do you say there, Jake? What do you think? Can you come up with another congruence there? Nope. Okay. Jackson, want to help him out?
Angle XWY and ZWY.
Are going to be the same? How would you know that?
Because YW is bisecting.
It's bisecting XZ though, so all we can say is that W is the midpoint, and we're going to have these 2 congruent segments there. So, but I think you're missing something else. Yeah, Luke?
Is YW congruent to YW?
There you go. That's an easy way to go with it, I would say at least. You got YW congruent to YW. And Avery, is that what you were going to say too? Yeah. Jake, do you see that? Okay. So anytime you're sharing a side, right, that's going to be a congruence. Okay. Oops. Where did I get? Sorry. This is not supposed to be triangle XYW. This is supposed to be angle XYW is congruent to angle ZYW. My apologies. Okay, sorry about that. So prove angle XYW is congruent to angle ZYW. So here's how we know, Jake, that it's a CPCTC proof. The thing we're trying to prove it's not a triangle. It's not triangles, it's parts of these triangles. Okay? And we know it's CPCTC again because we've got 2 triangles in here that we're going to use. So basically, it's the same thing we've been doing. We're going to prove these 2 triangles congruent, but then one more additional step, we'll say that these 2 angles are going to be congruent, therefore, because corresponding parts of congruent triangles are congruent. Okay? Jake, what congruence do we have here? Angle, side, angle, side, angle, side, angle, angle, side, 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 side. What? Mm-hmm. What triangle congruence theorem would we use? Side, side, side. Exactly right. Because you got 3 pairs of sides congruent. Okay? So we'll go through our typical proof, right? Pretty straightforward here. You start with the given information. So I'll just go ahead and do that. Bisects XZ. XY is congruent to YZ. Given. Okay. Then we'll state what you said there, Jake, that XW was congruent to WZ. And I'll just use like definition of midpoint or something like that. Whoops. Okay. And then we'll go ahead and state what Luke said too, that YW is congruent to YW. And that is because of the reflexive property. Okay. And there are 3 side congruences right there. And so you can state the 2 triangles are congruent. So we'll say triangle XYW. XYW is congruent to ZYW. By, like you said, side, side, side. Okay? And then last step, right? So we prove the triangles are congruent. So since we proved the triangles are congruent using their sides, we now know that all the other corresponding parts are congruent, right? These 2 triangles are congruent means that all the sides of this triangle are congruent to the sides of this triangle, but all the angles for this triangle are congruent to their corresponding angles over here. So angle X is congruent to angle Z, angle XWY is congruent to angle ZWY. That's all by CPCTC. And so we can then state here that then XYW will be congruent to ZYW. By that additional statement of CPCTC. we've already proved the triangle is congruent, so that we can use the fact that corresponding parts of congruent triangles will also be congruent, and that's our final reason there. Okay, so that's the only additional piece you need to do. It's a triangle congruence with then the final statement being the part that you're trying to prove congruent because of CPCTC. Okay, so does that make a little more sense there, Jake, about what to do? All right. Any questions on CPCTC? Any questions on CPCTC? Okay, so that's that. Again, we'll get more practice of that. I've got some homework for you to do on that. And I think we will stop there, actually, and let you guys get started on your assignment. So that'll be a good half an hour there to get work done, okay? So there'll be some more opportunities for practice in the assignment, okay? The assignment is actually already up on Google Classroom, I believe. Let me check, though, just to make sure, because I think there might be one addition I want to make to it there. Okay. Let me see.